Hi, this is Dr. John Bergduff. In this video, I want to show you a wonderful tool that is available to discuss the addition of integers. And these tools are called integer chips, or sometimes called integer tokens, one or the other. And you can see right here that what I simply have are they're poker chips. Some of them are black and some of them are red. They're actually commercially available integer tokens or integer chips. Those tend to be two-sided chips where one side is yellow and the other side is red. They use yellow for positive and red for negative. I kind of prefer thinking of black for positive and red for negative. And although the tokens are the commercial tokens are very easy to find, if your school district has a little bit of difficulty with paying for those, you can buy some plain old poker chips at any store. Have them be two different colors, black and red is what I prefer. And these work just as well. And I'll show you how all that works in just a minute. I'll also tell you why I like the colors black and red personally. I'll get to that a little bit later. But before I expose how we can use those to talk about adding integers, we need to have just make sure we have some commonality of some basic definitions. What are integers? What do integers look like on a number line? And what do we mean by absolute value? I'll be throwing all those words around. So the integers are simply the whole numbers and their opposites. The whole numbers are the numbers 0, 1, 2, 3, 4, 5, and so forth, going on forever and ever. And their opposites are -1, -2, -3, going on, and so forth. So we're going in both directions, negatives to the left, positives to the right, larger numbers to the right, smaller numbers to the left. Those are the integers. Easy to draw those on a number line. So let's just put some of these on a number line. Number lines help us get the sense of greater than and less than. Numbers farther to the right are greater. Numbers farther to the left are less than. These numbers are greater going this way. These numbers are lesser going that way. We'll come back to the number line immediately because we're going to talk about absolute value. Absolute value is a very important concept when you start introducing negative numbers because it gives you the idea of distance. Let's say you have a number A. This A represents any integer. And this symbol with the two vertical lines represents absolute value. The absolute value of the number is the distance between A and 0 on the number line. So if I think about my number line up here and I ask myself, what is, say, the absolute value of -2? Well, -2 on the number line is right here. The absolute value is the distance. How many units are there between -2 and 0? And in this case, I'm not going to care about the fact that the -2 is to the left of the 0. Just like later, I'm not going to care about +2 being to the right of 0. What I'm simply doing is going to count the space. I'm going to count the spaces. There's 1, 2 spaces. So the absolute value of -2 is that distance, the number of spaces. And what you'll immediately notice from that definition is if I switch to the absolute value of +2, that's the same number of spaces, the same distance. So the absolute value of -2 and the absolute value of +2, they're both 2. That idea of distance, that idea of absolute value gives us a way to focus on what many people sort of call casually the number part of the number while ignoring the sign. The sign just tells you whether you're to the left or the right. The absolute value tells you how far. So hang on to all of these ideas. We'll need them as we go along. Put that out of the way. and get to talking about these chips a little bit more. So let's bring some of them back on the page. Let's just bring out one of each to begin with. So again, what I like to do is I like to represent or let the black chips represent a positive number. So a single black chip represents the number 1, positive 1. A red chip represents a negative number, so a single red chip is a negative 1. Now, why black and red? Why is that so cool? Well, much farther along, if students get into the mathematics of finance and they begin talking about accounting, accountants use black numbers to represent positive, and so you'll talk about being in the black, and red numbers to represent negative, and you talk about being in the red. So black numbers are positive, red numbers are negative. This just sort of begins to set people up for thinking that way. Absolutely fine if you use yellow and red, or in fact, if you use blue and purple or any colors you want, but this is why I choose black and red. Now, a very important thing to make all of this work is to think about what happens when you have a black chip and a red chip together. So since I've brought up money, let's talk in terms of money again. Let's suppose that the black chip means that you have $1. I have $1. A red chip means that you owe $1. You borrowed money from somebody and you owe that back. What do you really have? What is the value of your fortune if you have $1 in your pocket, but you owe $1 to somebody? Well, if you have $1 and you owe $1, your total value of your great fortune is 0. You don't have anything. The positive 1 gets marked off or canceled out by the negative 1. To make the integer chips work, building on that idea, what we say is if we have a black and a red together, that carries the idea of having $1 and owing $1, and we refer to it as a 0 pair. Hang on to that idea. If I pair up a black chip and a red chip, it results in 0. Hold on to that thought. It's called a 0 pair. All right, let's get busy talking about how we use these chips to describe addition. Let's start with an example that you can go all the way back to first grade, maybe even kindergarten to look at. 4 plus 5. So if I represent, because they're both positive, the number 4 as 4 black chips, and the number 5 as 5 black chips. When I talk about adding chips, what I simply am doing is I'm going to put them together. Adding carries the idea of just putting it together. This is something that kids way back in first grade, kindergarten can play with easily to get the concept of addition of just plain old whole numbers. 4 chips, 5 chips added together means you put them together. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 plus 5 is 9. And kids at a very early age can just play with chips and begin to explore number facts. It's a very kinesthetic way to explore addition. Those are positive numbers, and we know about those all the way back in first grade. What about negative numbers as we build into integers? What if you have -4 plus -5? Well, you know what? Basically, there's not a great deal different here. It's just that you represent the -4 with 4 red chips and the -5 with 5 red chips. So there's not a whole lot different here, as you see. It's just 4 red chips put together with 5 red chips. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9 red chips. But since red represents negative, -4 plus -5 is -9. Now, if you look at these two, so I hope that makes sense. And you can simply have kids at a higher grade level just play with a bunch of these as well, just getting the sense of how the addition works together. But if we look at these two examples that we have here, you see that there's a lot in common. These two numbers have the same sign. These two numbers have the same sign. 4 plus 5 is 9. That's actually the sum of the absolute values of these two distances, two numbers. If you focus on the distance from 0 and not the sign, 4 units away, 5 units away, 4 plus 5 is 9. The only difference is if you add two negatives, the answer is negative. If you add two positives, the answer is positive. How might we put that into a rule? And this is eventually where you want your students to get. You might have them play with chips to give examples for quite some time, but eventually we need to get to a rule something like this. If we want to add two integers, if the signs of the integers are the same, what we will do is we will add the absolute values of the integers and we'll give the sum the common sign. So the common sign when I add -4 and -5 is negative. The absolute value of this number is 4. The absolute value of this number is 5. 4 plus 5 is 9, and the common sign is a negative. Once students feel comfortable with playing with the chips, they can continue to do examples with the chips, or they can simply say, well, let's follow the rule, so to speak. -12 plus -3, these two numbers have the same sign. So I'll add the absolute values. Those are the distances from 0. I'll add the 12 and the 3. That gives me a 15, and give the answer the common sign of a negative. So I hope that makes sense, and that looks like a nice way to illustrate things. Now, it gets more interesting. Oops, that was out of place. I'm so sorry. Don't want to give that away. It gets more interesting if the signs of the numbers you're adding are opposite. But let's just think about our chips. 4 would be represented by 4 black chips, and 6 would be represented by 6 red chips, like this. Adding carries the idea of putting together. And at first glance, it looks like maybe we have a mess, because if you have 4 black chips and you put them together with 6 red chips, well, you got a bunch of black and red chips. And that doesn't seem to do any good until you think about the idea of the 0 pair. What if when we put these together, we do it in a clever way where we match up as many blacks and reds as we can? So as far as I can, I'm going to combine or put a black and red together. Every one of these black-red pairs is a 0 pair. It represents a 0. So this is a 0, this is a 0, this is a 0, this is a 0. All these are 0. You can take those away. And what you end up with is 2 red chips. 2 red chips would represent -2. We'll do another example with the chips so you can see that idea of 0 pairs and how that goes away. While you're looking at this, though, look at what the answer turned out to be and think about the absolute values of these two numbers. The absolute value of this is 6. The absolute value of that is 4. 6 minus 4 is 2. Somehow the answer comes out negative. We'll focus on why that is at some point in the future, but there seems to be something going on. Even though we're talking about addition, somehow we seem to be doing subtraction. Hold on to that thought. Let's do another example so we can see those 0 pairs working. 4 plus -3. So 4, again, that'd be 4 black chips. We get those going. Oh, that's enough. And we'll get 3 red chips. Again, at first glance, you say, well, that doesn't do any good. I've got a bunch of black chips and a bunch of red chips. How do you put those together? Combine them in such a way that you create as many of these 0 pairs as you possibly can. 0, 0, 0. All of these are 0 and they go away. This would be the result. As you can see, it's a black chip, so that's a +1. And thinking about the absolute values of these numbers, 4 minus 3 is 1, so there's something going on with subtraction again, except on this example, the answer was negative, and on this one, it's positive. So again, you would let your kids play with many examples of this kind, but you want to lead them towards an understanding of a rule. And hopefully we're already seeing that somehow when you add numbers that have opposite signs, you don't add the absolute values, you subtract them. How do you decide what the sign is? Well, a very common thing that people will say is, oh, give the final answer the sign of the bigger number. And you can see what they mean. You say, oh, look, -6. That means there were more red chips, and the answer turns out red or negative. Bigger number, that's the sign you get. Bigger number here is positive, that's the sign you get. There's a problem though, because this is not the bigger of the two numbers. We have to fix that statement just a little bit. If you think about where these are on the number line, 4 is to the right, -6 is to the left. So which one of these numbers is bigger? This one's bigger, not that one. The way you can fix that is to say, oh, focus on the number that is bigger in absolute value. Which number has the bigger absolute value? And that's going to give you a rule that you can use, which I will show you here. To add two integers, if the signs of the integers are different, you don't add the absolute values, you subtract them. Subtract the absolute values of the integers, larger absolute value minus smaller absolute value, and give the sum the sign of the number that is larger in absolute value. So when you have 4 plus -6, the number that has the larger absolute value is this one. So the answer will be negative, and you'll get the absolute value of the answer by subtracting the two absolute values. 6 minus 4. 6 minus 4 is 2, so the answer is -2. I hope that's helpful. I love these toys. They're really great for teaching the concept of addition. The zero pair is the key idea that makes it work. The cool thing is that these same chips can be used to talk about subtraction and multiplication. And I have some future videos planned where I'll show you how to do that. So stay tuned.